Hi everyone, I am Courage Irene and I'm here with my colleagues.
I am Brett Hillary.
And I'm Pio Adrian.
So we are going to take you through our project, and our project is the detection of anemia from the conjunctiva images. So the next slide has the contents of the presentation, where we have the introduction, the related work, the problem statement, the research questions and objectives, the methodology, the dataset description, the conclusion, then the anticipated limitations and the references.
So a brief background and introduction to our project. First of all, since we're dealing with anemia, I want to first analyze about anemia. Anemia is a common health condition caused by low hemoglobin levels in blood, which reduces the body's ability to transport oxygen. So anemia detection is something done by most doctors in most hospitals, and so it's usually the first step that they undergo in many cases. Anemia has usually been diagnosed in Uganda using blood samples, although now the world is growing and people are looking for more non-invasive ways. By non-invasive, I mean you don't have to directly use the body by injecting or drawing blood. You can actually just use external features. For example, the eye conjunctiva has been taken as a serious example in this case. The color of the conjunctiva can determine whether someone is anemic or not anemic. If it is red, it means the person has blood, and if it is pale, it means it has less blood. That's anemia. Yes. So before doing our research, before doing our work, we made some research on related works that have been done before from different scientists and software engineers over the world before. So as you can see, now these are some of them with the links provided there. So our problem statement for this project, we have split the problem statement into two. We have the domain application problems, and these ones affect more of the population base. As we can see, anemia affects millions of people, especially in areas where people lack medical lab facilities to test it. For example, currently, it's through blood samples, which is an invasive method because you have to inject the body, and it's also expensive and inaccessible to many. So we are creating a first non-invasive method to enable this anemia detection process. Yeah. So now for the computational problem statement, now this is where our developing part comes in. We want to develop a reliable computer system to detect anemia rather than injecting and drawing blood samples. As you can see from the image here, you can use the status of the conjunctiva. As you can see, if it is red, you're safe. If it is pale, it means you lack blood.
Okay, I'm taking you through research questions. That means the questions that were able to conduct. Can machine language models accurately detect anemia using conjunctiva eye images? How strong do color features of the conjunctiva correlate with hemoglobin? Which conjunctiva region provides the most useful feature for anemic detection? Can image-based be used to classify patients as anemic or non-anemic? How effective is a non-intrusive image-based approach compared to traditional hemoglobin-based diagnosis? And then we have the methodologies and architecture, so the steps that we are going to take through while conducting our research. One is image acquisition. That means you're going to capture an image using a smartphone or camera, and then pre-processing. We enhance the image quality, normalize the lighting, cropping the region of interest, and removing noise. We have future extractions. That means extracting colors. That means the red, the blue, and the texture. And then other visual indicators correlated with hemoglobin. And then we have model training, pre-processing. That means using now machine language. That's now where the real code comes in. And then the result output, displaying the categories. How severe is it? And then we provide some recommendations.
So every machine learning model needs a data set, and the first step is to analyze the data through the exploited data analysis. So from our project here, we discovered the best data set was the IDA anemia data set that we got online, and is the best that we can work with right now. So this data set contains different folders, and we have a total of 218 folders. So each folder comes with 4 images. Each folder comes with 4 images. And from these 218, it's from patients from all over Italy and India. So 123 patients are from Italy and 95 from India. So now each image in this folder is associated with 3 factors, which is the hemoglobin value, the HbG, the gender of the person, whether male or female. This data set that we are using is intended for basically 3 main purposes. The first is non-invasive anemia detection, as earlier stated. Then image segmentation research. We're going to split the conjunctiva into different sections and analyze it. Then the third is computer vision analysis of the conjunctiva power, basically the entire conjunctiva, understanding it very well. So before we start our output results and discussions from the exploratory data analysis that we've done, EDA, we first have to understand the variables that we shall use in our data set. So the number variable here represent the patient ID. The HbG will be the hemoglobin level, which is measured in grams per deciliter. So then the age of the person here will be in years, the gender, either male or female, the country is Italy or India. Then for the image, when you are analyzing the image basically further, we shall deal with the RGB values, the mean red, mean green, and other. So we did a basic understanding of the data cleaning, whereby we found that one value is missing, and that was patient 93 from Italy. So we did a decision to remove that patient out and then work with the data harmoniously without it included. So basically, we have analyzed the demography of the data set you have seen here. We have distributed the age the age population of the different patients here, as you can see in the bar chart and so the bar graph and the pie chart you've seen there. Yes. Next, we also did the hemoglobin visualization. We saw the hemoglobin distribution among the different patients, and we also split them in terms of gender and age. Yeah. We went further to categorize the hemoglobin variations in the bar graph based on the country and gender. As you can see, male Italy, male India, female Italy, female India. Yes. Then last year, under hemoglobin analysis, we did a hemoglobin distribution for gender and found the geometric distribution as well from the curve you see on your right-hand side here.
So this is the eye sample that we got from our data sets. This one, it shows the conjunctiva is very pale, meaning the person is anemic. And then this one, it shows there is some blood, so the person is not anemic. So now next slide.
Okay. Here we have a histogram showing the red, green, and blue pixel intensities are distributed across all images, helping you to see which color are more or how they vary. And then this other one, we have this plots this histogram here, as you see it, plots the overall brightness of the image the brightness of the image. And then we're looking at how it is distributed, how the brightness is distributed, letting you to see the brightness level and rest. Okay. And then here we have the demonstration of the developed product now. Here we are looking into the developed system uses machine language to detect anemia for conjunctive eye images. So if an image is uploaded into the system and then the model analyzes it. So in the due process, we expect you to be getting results like, are you anemic or non-anemic? And then thereby reducing on the chances of you using your blood instead better than you are best using images.
So we have some conclusions here and the limitations. So the conclusion, this study shows that the conjunctiva eye images can be used with machine learning techniques to help detect anemia non-invasively. Then another conclusion is by analyzing color features related to hemoglobin levels, the model can classify patients as anemic or non-anemic. Then this approach has potential to support faster, low-cost anemia screening, especially in areas with limited access to laboratory testing. Then the limitations, it has a small data set size. The data set contains images from only 218 patients, which may limit the model's ability to generalize to a larger population. Then the suggestion, future studies should include more patients from multiple regions to improve model reliability. Then the next steps for the real-world testing, The model should be tested in real clinical environments using images captured with different smartphones and lighting conditions. Then to develop an automated segmentation. Future work should focus on building automatic algorithms to detect and segment conjunctiva regions without manual annotation. And then these are the references that we looked at as we were doing our project. Thank you very much.
None gone.